Hello everybody. In today's video, let us see about system programming, the same chapter unit 4, macro language and macroprocessor. In the last video, we discussed that how macroprocessors are implemented as well as macro calling macro itself, that is macro defining macro itself is discussed. So we already discussed that what is microprocessor and how it works, and we already discussed all the data structures in the last video, right? We use different tables, we use the different data tables, data structures, etc., right? So in the continuity of the same, let's have just a recall of that. So we know that the 4 basic tasks, that's the same repetition what I am having right now. So I know that the macroprocessor works in a 2 passes algorithm. So what it does 4 tasks, that is identify the macros. How it identify? Using a macro name it identify, and rest everything is a definition of a macro it identifies and it saves. So these 2 is a pass 1, and next it will search for the name of a macros in a program. If there is a name of a macros in a program in a mnemonic field of a program line, then it will expand. So this is pass 2. So this we discussed, and we discussed how the tables are arranged. So you have these are the macro definitions, and macro is called in a program somewhere. So whenever a scan is made, first scan it will scan and create the database like MDT, MNT and ALA. 3 are the basic things which required. The rest of the things are not so much important. That's what I had told the specification. Yeah? So while scanning a program, this is what a program, it is a scanning. When scanning a program, it come across that there is a macro. So it understood. Next is a definition of a macro. So pass 1 in a first scan, it will scan macro. Then it's a pass 1. So INCR is that. INCR, it will substitute in a macro name table, and everything till end is stored in a MDT. So whenever it is storing an argument list is created. According to the list, how the numbers are given, the numbers are substituted in the MDT. Till end it is stored. That is what the first scan. Okay. After completion of a first scan, it will go for the second scan. While scanning, it searches for the macro name. Yeah, here it's a macro name and there is a match with the table. So whenever match is found, it will select the position of a INCR macro in a MDT. It is in a position 5. So it will come for the 5th position and it will substitute everything till the end. Not till the end. We are not including end, but till the before the line of the end. We are substituting, and 0. Nothing but it is substituted the arguments whatever it has been passed. Here no argument has been passed. If you are passed an argument, then the argument will be replaced these dummy arguments. So this you know. So on the basis of that, we'll go the flowchart and algorithm. So in a first pass 1. Here pass 1 will initialize both the MDT and MNT counter as 1, means it's set for the first line. No, at the pass not even a macros are encounters till the starting pass 1. So the first line has been, that is counter is in a first line. Next, read and write text. It will start reading. If there is a macros, if there is any macros, that's what in the previous. If there is read a text, first it has set to the first line. You can see this is the first line. Here also it was in a first line. Yeah, it's the 5th, means you have second macro it might be clear. So MNT C is a counter of MNT, MDT C is a counter of MDT table. Both are set to 1. Pass begin. Pass will scan from the first. Read a text if there is a macro. Yes, there is a macro. Then if it is a S condition, then it will read the next card, next line, and put the macro name in a MNT and increment MNT. Similarly, put the values of all the definitions to MDT and increment the MDT and prepare the argument list array. So this is what the full explanation. Clear? It will search for the name and find out that it's a definition. So it will enter into every name till end will be, all the arguments will be loaded into MDT. Similarly, name is loaded to the MNT, and MNTC, MDTC incremented and ALA is prepared. Then it will go for the next read source. If in case there is no macro, then it will simply write the source code directly as an output for the pass-through. Yeah. Then it will go MDT. This task is continued. That is what line number, that is what here the first line. Yeah, this line will be seen macro is encountered. So the next is a line number, that is what the second line might be. So that will be incremented, the name will be incremented over here, and MNTC is incremented to 2. Now the next, if you have any macro name, then it will be encountered. Over here, each line, so fifth line is AND lab, ALAB, INCR, argument 1, argument 2, 3. Next again MDTC incremented and #0 A2 comma #1 is loaded. Again next again MDTC incremented and A2 comma #2 is loaded. So like that all the lines, each and every time MDTC is incremented until end it is loaded for each line. Next, if you have any new macro, then that will be loaded in a 10. So that's what the task happen over here. Clear? It will search for the next. If you have any argument, then substitutes its index notation instead of writing the name. Yes, see over here this line, when I am writing reading over here, I have when I doing a scan, when a macro is doing a scan, this scan it will give the argument array. Argument array will be created. For this it has been given 0, for this it has been given 1, and argument 2 it is given argument 2, and argument 3 the number index number is given as 3. So when it scan, this will enter, INCR will be entered into MNT, and all the arguments are listed in the ALE. In the next scan, what it will do, it will substitute the index number whenever it occurs in a MDT. So you can see that this line is #0 A2 comma, that need to be 1 comma #1, A2 comma #2, 3 A3 comma #3. That this is, there is some mistakes, 1 2 3 it need to be clear. Whereas the #1 #2 #3 is the number given over here. This is as it is. This is not the first register is used. 1 comma ampersand A register, 2 comma ampersand 2 register, sorry, argument 2, and 3 argument 3. Clear? So that will be incremented. So whenever there is a amend, it stops. If there is no amend encounter, it will repeat. Means all the lines, all the model statement, we had 3 statements, all the 3 statements are entered to the MDT, as well as MDTC is incremented, and it will point to the line number 10 for the new macro. If there is an amend, again it will, if there is no amend, then it will repeat this task. If it is an amend, it will come back to reading and source. Again, if you have any macros in a program, then it will repeat the steps, else it will come out and go to the pass-through. Clear? When it will go for the pass-through, when you encounter the end of the program. When the end of a program is encountered, it knows that all the macros are defined. If it is not end of a program, again the task is repeated. If it is end of a program, it will go to the pass-through. So this is what the algorithm. Initially MNTC is initialized to 1. It will read the next source. If there is any macro, then macro definitions are saved in the next available MDT. Macro name is entered into MNT, and the pointer of both will be updated. ALA is prepared. Clear? And all the lines, each and every lines are entered to MDT. Similarly, MDTC is also incremented. Next, if there is a amend occur, then it will again go for the program, and again it will read. And if there is no macro left out, means all the first scan complete, means there is no macro again, then it will write the copy of a source code, means all the macro defined a program, source program has been copied. And at the last, if there is any end, then it will go to the pass-through. means first scan completed. Now we need to go for the second scan. So that is what the pass to. This is what the second scan. In the pass to what it should do, again it should scan. Again it should scan and it should check that whether there is any macro name in a program. So again it will scan. When you reach the end, again this is first pass. Again in the second pass, again it will scan. While scanning, now it is not checking for the macro, because in the first pass that is checked and all the pseudo ops are of a macro, that is nothing but it consider it as a definition and it has been stored. Right? In the second pass, it will search for the name of a macro, so that it analyze that it's a call. In the second pass, it should check for the call. Yeah, over here it has been called. Then it should be replaced by the definition, its definition, that is 3 lines of a definition it should replace. So what it will do, it will go INCR, it will go for a MNT and get the pointer. From here pointer, it will get 3 lines. It substitutes. While substituting this index number, it will substitute the actual argument whatever you had given. Yeah, so you'll see that over here. Check again, it will start reading source program and it will check if there is any macro name, means it will start matching with the MNT entries. If there is any name of a macros found, then it will get the index from MDT entry of MNT, that is 5. It will be passed to MDTP and the pointer points to the 5th line of MDT. Set up the arguments. We'll say get the argument instead of 1, 2, 3. It will set up all the arguments which has been passed. Okay, next you have increments, one line by line by line by, all the 3 lines are incremented. Get the line, all the lines are retrieving from the definition where it has been stored and substituting all the arguments. Clear? This process means you are substituting A1 comma data 1. If you send a macro call as INCR data 1 comma data 2 comma data 3, then you are substituting how? You substituting the argument means A1 comma data 1, A2 comma data 2, A3 comma data 3. All the everything is fine. All the 3 lines. After that, the next, whenever we incremented this MDT, if there is an amend, if not, then repeat. Means A1 comma data 1 will be substituted. Again check for MDT. No, it's not an MDT. Then again go back. A2 comma data 2. Again amend, next line is amend. No, then again repeat the task. A3 comma data 3. All 3 lines are over and the next line in the MDT is amend. If it is an amend, then go to the source program. Again search for the macro name. If there is no macro name, then you have end with the expanded source where you don't have any of the macros. It will search for the end of a program, means all the complete second scan has been completed, so that you will get all web output, which is nothing but a program where you don't have any macros. Clear? You don't have any macros as well as a macro call that is substituted to the assembler for the further process. So this is what pass 1 and pass 2. So this is what the algorithm of a pass 2. So you will get the copy of a pass 1. Again the copy whatever you will get, the source program is scanned. So again read the source program and search for MNT if there is any MNT, like matching with the search an MNT for matching with the operation mnemonic code. Mnemonic field element is matched with the MNT. If there is a match found, if macro name is found, then processor what it will do, it will MNT index whatever you will get in a MNT entry, that is what the 5 I told, that will stored in a MDTP, and that value MDTP whatever value you will get in for that entry, it will initialize the value for MDTP. Clear? And it will set up an ALA, because all the dummy arguments to be replaced with the corresponding argument. So ALA is a setup. AL will be set up for replacing, means 0 hash means it is replaced with the loop, hash 0 is replaced with the loop, hash 1 it is replaced with the data 1, hash 2 is replaced with the data 2, hash 3 is replaced with the data 3. So we are dumming argument replacement. We use set up the ALA. ALA is nothing but argument list. Clear? Next, similarly all the dummy variables are substituted, and meantime MDTP for each line it is incremented for successive line. Clear? Next, if there is any amend, then all the model statements are substituted. If there is no amend, repeat the task. Next, if there is an amend, then terminate the and scanning continues to the next line. Again, if there is any macro name found, then repeat the whole steps, else go for the expanded source book. And when there is an end, you will get a file where you don't have any macros. That is what you have, an expanded source file where all the macros are expanded, which is given to the assembler for further processing. So this is what a pass-to algorithm. So we discussed with the pass 1 as well as a pass 2. Macros can also be implemented in using a one pass algorithm, nothing but a single pass algorithm. So when the single pass algorithm is used, single pass algorithm is used when we have a macros defining within a macro. A macro is defined within a macro. That time we use the one pass assembler. Clear? We had a restriction that we are not considering a macro defining within a macro. Means we discussed the first method or a two pass algorithm where we are not considering this method, that is macro within a macro. We are just all the macros are defined. We don't have any other macro defining within a macro. Means when the macro is defined and you are calling somewhere, means just a substitution of that macro over here. But if you are defined a macro, inside that you have one more macro. Clear? When scan, it will search for a macro name and it will store. Whenever you will call over here, that time only it will search for the expanded source. That time if you have again encountered a macro, what will be the problem? It need to be defined. Clear? Until it is not defined, you cannot substitute it. Right? So in that case, we cannot have a two pass algorithm. We need to go for the one pass algorithm. In this, you can see that you have macros in encounter. Imagine we have scanning. In a one pass, what happen? It will scan. When it will scan, it will search for the macro. Yeah, there is a macro. It will enter, define in a empty table, and it will start writing everything, whatever you have, each and every line in your MDT. Meanwhile, all the arguments are replaced with the corresponding index value. So whenever there is a defined, MNT is entered and completely everything will be stored in a MNT. This is not defined. Okay, this is not stored. We are stored defined. You are not stored sub. Clear? When sub will store, when you call a define, that time it got expand. While expanding, it encounter a macro again. So that time it should define, because you are calling a macro within a macro. This consideration is not done in a pass 1. Two pass algorithm. So we need to have second algorithm, that is nothing but a one pass macro, in which in a single pass the define as well as the calling, means define in the sense, define is nothing but searching for the macro, definition and storing, and calling means searching for the name of a macros and substituting. Both the tasks to be occur in a one single scan. That time only I can define that. Again I can define this. Next, whenever I call this, the cause can also be called. Else I can't call the cause. Until it defined, I can't call the cause AR. If I want to define the cause, I need to call define cause. Whenever I call the define cause, that time only it will define. So this consideration we use in a one pass macroprocessor. As algorithm, it is used when a macro defined are within another macro. Macros are within another macros. Then inner macros is only defined only after the outer has been called. Means outer should be defined, it should be stored, and in the second pass when it call, that time the inner macros will start defining. Clear? Pass 1 task is done in a pass 2, which cannot be done because pass 1 and pass 2 are segregated, as pass 1 only defining an macros and pass 2 is only calling a macro. But over here what happened, when outer macro is called, that time inner macro is defining. So it cannot be done in a two pass. So we need to have a single pass. So here in OnePass, what we are doing, we are processing both inner macros, that is what the definition, and the call. Defining also we are doing, call also doing repeatedly, one inside the another. One is calling and other is defining. Clear? After a call, another macro is defining, means we are repeating the task of defining as well as the calling. That time we need to use, or we need to reduce your macro two pass macro processor into single pass processor. In a single pass, it should define as well as it should call. Clear? So because we know that this is the main thing, we cannot call any macros until it has been stored. Clear? If it is stored, then only I can expand, else I can't expand, because if I store, then only I'll get the model statement. That these are the 3 model statement or a 4 model statement that should be substituted whenever there is a macro call. For that reason, we reduce the 2-pass algorithm into single pass algorithm. So what we have in a single pass algorithm? Single pass algorithm we discuss using a flowchart. There is 2 flowchart. Both are executing together. These are not different. These 2 are single algorithm which is explained with the 2 different flowchart due to the what we call the space management we have divided. That's it. Clear? So to perform this, we use 2 additional data structure. We have MNT, we have MDT, we have AL. All the data structures are there. Along with that, for OnePass, we are using 2 more data structure. That is, one is macro definition input indicator, MDI we call it as. Second one is macro definition level counter. These are the 2 counters used to calculate or keep a track of how many calls are there, how many definitions are there. If there is 10 calls, then 10 definitions should be there. Clear? If I am calling only stored 9 definitions and I am calling the 10th one, means I can judge that any one macro is not defined. That time it should be defined. So for that purpose, we use these counters for the counting how many macros, macro calls and macro definitions are there. If there is 10 definition, then 10 call will be there. So that is what we'll go one by one. What is that structures, data structure? First one, MDI. So MDI is nothing but it's an indicator. It is performed in the read box, means we have 2 algorithm I told, right? So it is in a read function. It will execute in a read function. So what it will do, it will check. It's an indicator. It will check. That is, if it is on, then it is macro expansion is going on. If MDI is on, means macro expansion is going on. And whenever there is no macro expansion, it will be in a off mode. Clear? Whenever there is expansion of a macro, means there is a macro call. It will indicate there is a macro call. Clear? So whenever the macro call, you need to search for the defined. If there is a defined, then it can substitute. If it is not the defined, then it cannot be substituted. So identify that if it is MDI is on, then during when expansion is taken place. Clear? Its value is on, and means you are expanding. Whenever you are expanding, you are taking the line from MDT. You are reading the line from MDT, and when amend will encounter, MDT will have amend. When amend line will encounter in MDT, will feel that all the model statements are expanded. Clear? Then it will set to off. Understood? So it will only on when you are reading a model statement, means whenever you are expanding the call. Second counter is MDLC. MDLC is nothing but it is macro definition level counter. It incremented by 1 whenever macro is encountered. So this is used to identify how many definitions are there. So whenever there is a macro comes, this is definition 1. Second macros come 2. Third macros come 3. So there are 3. Then you can have 3 calls. If you are calling 4 macros and you have only 3 macro found, then one is not defined, that is inside the another. You can find out. So for that we are having MDLC. It is search for how many macros are there. Whenever it found a macro pseudo up, it will increment, and whenever there is an amend, it will decrement. Means one macro is defined, then it will decrement again. Clear? Here it ensures that help me to store the definition in MDT, means how many macros. For example, 3 macros are there and you have defined only 2. Then it's updated for 3 and you are defining only 2 because you are getting that definition only within another macro. Then it can encounter that one macro is not stored. For that it is used. So it is ensuring that there is all the macros are storing in a MDT. If stored, then I can call, because after storing I can go for expand, right? Here it is a counter which points difference between the number of macros and amend. So one macros you found, then there should be one amend. If the macros is found, it tells that how many macros are there and how many amends are there. So if you have 1 macros, then there should be 1 amend. If you have 2, then you have 2 amend. If you have 3 macros encounter but you didn't find the macro amend still, then there are 3 macros encounter and it's not defined it. So it will have a difference between how many macros and amends are there. So how this is executed? In OnePass assembler, macro definition passes and macro call passes perform simultaneously, means definition and the calls, both the passes. This is pass 1, this is pass 2. Both the passes are work simultaneously. Clear? So whenever there is a simultaneously, it will macro definition pass create an ALA with index number #0, #1, #2, #3. Whenever a call was there, #1 is replaced with the data 1, and that is argument, actual corresponding argument what you are giving. #2 is replaced with the data 2, #3 is replaced with the data 3. So for this ALA is different, for this ALA is different, right? So it will create 2 ALA, separate ALA, one for the definition, one for the call in a 1 pass macro processor. Clear? Therefore there must be 2 separate ALA, one for the definition and one for the macro call. So I'll go with the flow chart. So go with the textbook, because I had taken a picture from a textbook as I can't include it, the complete. Yeah, go with the textbook, get your textbook. Hope you can see. So it starts a program. First OnePass algorithm starts. All MDT, MNTC, as you know, the counters are set to 1. MDI is off, means there is no expansion taking place, and MDLC is 0, means there is no yet a macro is encounter. Clear? Then you have a read. Whenever you have a read, it will come for the read option. If MDI is off, yes, MDI is off, then read the next. MDI is off means there is no expansion, you need to call for the macro definition. So it will read for the next statement. Whenever it reads the next statement, it will again and again, whenever it will start reading all the and return to the main program. It again and again read the main program, return to the main program. Here it will check for if there is any MNT. No, still any call is not defined, because call is not, any macros is not called. You have again macros sudo op, means definition is not stored yet and there is no macro call. Suppose in that case, then there is no macro calls, it will go for the no. What happen? It will come for the if there is a macro. Then it's a definition, it will read the lines and it will store. Whenever there is a macro, what it will do? This part is same. This entire part is same. What it will do? It will enter the name into MNT and MNTC is incremented. Prepare an argument list and it will enter all the details into MDT line by line. Both MDTC and M here you can check that MLDC is incremented, means first macro is encountered, and all the lines are entered into MDT till whenever you have a amend. Inside if you again have a macro within a macro, if there is yes, clear, then repeat the text by incrementing MDCL. So you will get 2 macros now, macro within a macro. Then repeat the same step, enter all the details into MDT. If no, then check whether there is an amend. If it is an amend, then decrement, because one has been defined. Clear? If again second amend you have encounter, if you have one macro within a macro, then again what you need to have decrements, and 2 macros are defined, one macro encounter I have entered one amend. MDLC is incremented 1, again decremented by 1. Again, if you have another macro encounter, then it will incremented by 1, and still again if you have an amend encounter, then it is decremented 1, and you need to check for if there is any other MDLC, means if you have macro within a macro. If it is not, because if you had 2 in the sense, now MDLC is incremented twice, decremented twice, then again it becomes 0. If it is 0, then it will come out of. If it is not 0, then again if it is not 0, then it will repeat. If it is yes, then it will go for the A means over here. That's what algorithm is written. If it is MDLC is 0, then yes, then it will go for the A. If it is no, then repeat the task. Means all the inner macros are defined now. One inner macro. This is the first macro where it will enter. It will search for whether there is a macro and start entering all into the MNT, MDT, everything. Again at the last, again it will search for a macro. If you have, repeat all the steps. If you don't have, then if it is and then decrement, means 1 or a 2 or a inner macro. How much you have, everything will be stored. So storing option is done in a pass 1. Again we return to the where A and search for the call. While calling, if you found a clear macro name, so it will go for the read. So now whenever there is an expansion, what it will happen, whenever there is a call, then it indicates that yes, there is a MDI, indicates that this is a call, and it will set to on. Clear? Which increments all the MDT pointer, because you need to get the model statement for the expansion. So it's a call. Whenever a call, it will increment MDTP, means it will get the index from here macro. It will search again while reading in a program. You have a macro name. It will search across the MNT. We already checked. Check the operation mnemonic field is matched with the MNT entries. If match found, then it is called as a call. So it is a call. Then it will set on MDI as an on, and it will get the pointer from MDT. These parts are same as you checked in a pass 1. Only thing is here a macros, again a macro is need to be checked. Here MDI should be set. Clear? And set up all the arguments and go for the read. When it go for the read, here it is not equal to off, it is equal to on, because we have set it's a call, right? So it won't come to this, it will go for this part, because we have a call within a call, and it increment all the MDT pointers and get all the MDT. This is for the macro inside a macro. One more macro if you have, then to call that macro this part. The previous we can call the outer macro, because we are getting all the line from the MDT, we are setting the arguments. Whereas here if you have a macro within a macro, then getting all those lines from MDT, substituting the argument and checking for an amend. If it is a checking for an amend, it will check for MDLC 0, means all the macros are called. If it is so, then it will set MDI again as 0, means all the expansion is done, and return to the read functions and return to the main program. Else, if it is no, then it will go for again checking, repeating the task. So this was the pass 1. So both the algorithm, it's a 15 marks question. You have an algorithm to be there is no algorithm. In an algorithm you need to specify that all the data structures are same, except it uses 2 more data structure. One is MDI and other is MDLC. For this algorithm, check your textbooks, because it's not clear. So we know that in OnepassMacros call, nothing but defining a macros, all the calls are working in a recursively. One macros is you are encounter, inside that another macro, again that need to be defined. So it is defining, inside that again it is defining. After defining this, again you need to complete the rest of the statements whatever we have in a outer macro, right? So when a macro call is encountered during macro expansion, macro processor should expand the macro call first, which is encountered within another expansion. Clear? After finishing that, it need to encounter the outermost, expand the outermost. This is what recursively it should have. means you are nested. Nested, how will do? You are expanding that. Inside that, if you have a call, then you need to expand that. Again, you are go back to that program and you need to complete. Right? So then it is working in a recursive. You are going back again, then again. That is what the recursively you are implementing. Right? So to handle this recursively, nested macro calls. Understood? You have an if condition, imagine. Inside that, if you have an if condition, then you need to process this first. After processing, again you go back to that if condition, right? So similarly here, one macro is expanding, inside that another macro is called, means expand that macro. After that, again come back to expanding the previous macro. So you are working the nested macro. Whenever you are working with a nested macro, then you need to store the return address, because you are leaving the task in the middle and you are jumping for the next macro, expanding, and again you are coming back to the previous expansion. So that time you need to save the return address, nothing but a status. So best method of storing the return address is stack, right? Because stack works in a last in first out options, you know that, and normally we told that each and every functions has a return address using a stacked data structure. So here also, for recursive execution of macros within a macros, we use the stack. So how the stacks are used? Yeah, how the stack is what we call that as organized so that it can have the return address. So we'll have, this is a macros. You can see that this is the first macro you are having, and this is what the second macro you are having. Clear? While writing a program, imagine this call occurs, add as data 1, data 2, data 3. Then it will go for this macro, add as data 1, argument 1 is replaced with the data 1, data 2, data 3. Inside that you are calling add 1, means it will go for the one more. Now it is nested. So it should go for this. It should encounter amend, then again it should come back to add as, that to line add 1, means you need to store the return address of next line. PC encounter with the next line, right? Again it should go to the add 1, expand this, again it should come back. Clear? If we are doing 2 pass, what happened 2 pass? It will start here, it's stored. Next what happened? When this is called add as, this is called, it will go back over here, it will expand, then again it won't return, because pass 1 is not 2 pass algorithm does not execute for recursively macro definition and macro calling option. It won't work. Recursively and again it won't jump within a functions. Clear? But over here I need to jump within a function, means add as, whenever I called add 1, it need to go, again it should come back. Again when I called an second argument, then again it should go and it should come back. And for third argument data 3, again it should go and again it should come back. At the end it can leave. That recursively was not done in a 2 pass, because all that defined and second time it's called, that's it. Recursive execution is not done, but in a one single pass we need to do that. Clear? So it should go and again come. So that's what I have written over here. This part you don't have in your textbook, this is for your reference, you can leave, and for you they'll ask just explain the structure of a stack, how it is there. To explain in a brief, I use this problem where you don't have that problem. You have this problem in a recursive or a nested macros. Same program I took over here. So you can leave this. These are the not, you cannot include these 3 slides, not needed. This is for your reference. This is 1, this is the second slide, this is the third slide. 3 slides you can skip on. This is not that, this is for your understanding purpose. Clear? So you will have a better understanding. You will just have a one pass algorithm flowchart. You need to explain the flowchart. That's what the 15 marks question. You need to write both the flowcharts. Apart from that, they'll directly go for the structure of a what we call it as stack. Clear? So here you can check that 10 lines of statements we are having. Clear? What happened? So consider an action. You have called add as data 1, data 2, data 3. When you have called that add as, then macro call list. ALA will be created and it will jump to the line number. Where is the line number? 6 here. Add as is in the line number this, right? So it will be in a line number 6. And MDI, it's a call, so it will set to on, right? and it will start reading from the line number 7. 6 is the call, so it will start reading. Means you called add argument data 1, data 2, data 3. Then it will jump to the line number 6 and start reading from the 7. When it starts reading the 7, it encountered with the another call, which is a call add 1, right? Then it need to again prepare a new argument list, because it has an argument list. What is the argument list? Data 1. New argument list for add 1. It has 3 arguments. It has given #1, #2, #3 might be. Again for this, again it's created one more argument list, that is #1, and jumps to the line number 1. So you can check that it will jump to the line number 1. Clear? And whenever it's set, it will read all the lines of that and set MDI is on for that, and it will expand till line number 5. Everything will be expanded, because when it encounter the M end, clear, it will expand. Then it set it to off. When it's set to off, what happens? Still address is not expanded. Address has one more line model statement. This is a call for this, right? It is not completely expanded, but MDI is set to 1, off. MDI is off means there is no call, but there is a call. Add 1 is a call now. Add 1 is call for the previous macro, but what happened? MDI is set to off. This caused a wrong, and we are not expanding the left lines of adds. Means add 1 data 2, add 1 data 3 is not expanded. Clear? Thus to handle this recursively calling, because recursively again and again you are calling, but it is not calling in 2 pass. It will ends up over there. M ends, it's end up, and it is not calling these 2. It is not doing recursive work. So in a single pass, you have done recursively work using the stack. Yeah. So how the stack is? This is what your textbooks you have. Stack is nothing but you have, it's an organized array, means you can point to the next memory location. So it's an array where you have arrays of pointers and the character strings. You have the pointers and the string stores in that array. Always SP is the top of the stack. There is nothing but a stack pointer. Clear? Next we have MDI. You know that MDI is used to indicate that how many calls are there. Clear? As we know that return address are stored in the top of the stack SP, so we can use SP, that is what the stack pointer, instead of MDI. No need of using an MDI, we can go with the stack. Yeah. And in a stack, always the successive frame, then succeeding from next frame always have the previous address, because you need to return it back, right? So previous SP value will be always stored in the successive or succeeding frames. Yeah. And in a stack you store ALA arguments, all the arguments, and MDT pointers are stored, and SP is used for indexing. Now we are not using MDI. Instead of MDI we are using SP. Why? Because SP is nothing but a stack pointer, points to the top of the stack. Top of the stacks gives me the return address. Whenever I have a return address and I'll go recursively inside a macros, then I need to come in a same order. That time I can say that there are n number of macros within a macros are encountered. So I'll come in the how I enter to the macro, in the same way I need to come out. So that's what the recursive. Instead of using MDI, we are using a stack. So stacks, you know that how you are stored. So once you entered, you will store. Second nested enter, you will store on the up. So your stack like this: 3 is stored, 2 is stored. So first program's return address is stored, and the second program return address is 3. Then how you will come out? You will come out from 3 first, after that 2, right? Last in, first out. So best is use SP instead of MDI. And in a stack you have a pointers and the characters. You store, how it will be stored? You are storing the argument array, that is arguments, and the pointer to the pointer of MDT. It is used as a index. So we will see the organization. So in the organization, S of P normally write like this in the bracket, means we are pointing to the memory location. this memory location always have the previous value. Yeah, for example, this is what you are having. So this is first macro frame, this was the second frame. So in the first SP, second, so similarly this is the first stack pointer, second, third, fourth, this is this for first macro, this is for the second macro, this is for the third macro, like that. This one frame for one macro. For example, if addS is called, then addS has 3 arguments, 1 2 3 will be stored. Add1 is called, then add1 has 1 argument, it will store 1 argument. Clear? So this is one for one macro call, this is for one macro call. Clear? So here first pointer always point SP, second is SP plus 1, this is an array. The first memory location S of SP always stores the previous return address. It always stores the previous return address. Clear? Next you have MDT pointers, because you have two things. You have MDTP and ALE. ALE list you need to store and MDT you need to store. So in the next memory location we will store the MDT pointer of the MDT table, and rest of the things we store the argument. So number of rows in a one particular macro depends on the argument. In a macro, if you have 3 arguments, then 1 for the return address, 1 for the MDT pointer, and 3 for the your argument. So totally 3 plus 2, 5 column reserved for the one macro. If a macro has only one argument, then 1 for the previous stack pointers, second is for the MDT, and third for the one argument list. So there are 3 column rows are assigned for that macros. So this is all. Here n means number of arguments in a macro call. So depends on the number of argument, the stack will substitute. In argument, if you send 3, then 3 plus 2 you require. So 5 space will be reserved. SP always points to the stack pointer, and S of M means we are talking about a content. So this is what the organizations. Clear? So this is what I have written. Check over here. S of SP is always points to the value of the previous SP, and that is what the first frame. If SP is equal to 1, then S of SP is the previous one. What is that? Minus 1. So we are talking about this point. If SP is 1, then content is its previous minus 1. If this is SP is 10, then the content previous is what? 1. That will be stored. If this SP is 15, then to return this is 10, so it will contain the 10. Like that all the data are stored. Yeah. So it is just like whenever I reach SP is equal to minus 1, means all the macros are expanded, means defined as well as expanded. So it is just like MDI is equal to 0. When MDI is equal to 0 means no expansions are taking place, means all the expansion has done. I have returned to the minus 1, means all the expansions. That's what I have expanding. I am getting inside the macro, nested macro, and when I am coming back, and if I reach minus 1, that means that all the macros are expanded. Yeah. Next, S of SP plus 1, that's what the next line will store the MDTP pointer. That's what I told, the second line. Here the second will be stored the MDTP pointer. This is also MDTP. Rest of the things will be arguments. That's what rest of the SP plus 2 to SP n plus 1, from 0 to n minus 1, all are you have a ALA. Yeah. So in the algorithm, what SP used, stack used algorithm, here not explicitly writing this MDTC plus 1, MD and MNTCA plus 1, the counters incrementation, because it's done, and we'll omit that just because to simplify the flowchart. Each and every time we won't, means in all the algorithm we have encountered that. You can see that MNTC plus 1, MDTP is 1. This is mandatory that it will perform. So as the algorithms are very huge, we are skipped in a stack, but inside it will happen, but we are not shown in a algorithm. That's it. Yeah. So imagine this is what happens. This is also not needed. Stack arrangement is done. That's it. This is for your reference so that you can understand this flow chart, which is very large. This is a stack. Using stack, how your single pass assembler works. So you can see, instead of MDI, in a read we used MDI is equal to off, but here we are using SP is -1. Whenever you come to the SP, then there is no call, all the calls are encountered. You had finished all the macro definition as well as the macros, and you are returned to the main. So same, but instead of MDI we are using SP. So you can check here both the algorithms, easy to score. You look that it's very tough. Clear? So you can check here MDI is on this part, and somewhere over here AIF, AGO, only these changes are there, rest everything are the same. Clear? Similarly, in the single pass, what we have done, we have MDI set to on. Whenever a macro is found, name is found, MDI is set to on. So instead of MDI we used SP. That's the difference. So in algorithm you can see the rest everything is the same. This part is same. This is defining a macro inside the macro. Instead of MDI we are using SP. Clear? So we'll go with the algorithm so I can explain this track arrangement properly. So I am using the same add data 1, data 2, data 3. You know that it's a 10-line statement. This program you need to remember, it's a 10-line statement. And 6th line is add call. Whenever you call add as data 1, data 2, data 3, you will point to the index number 6. 7, 8, 9 will execute. 7 will go for 1. Again 8 will go for 1. 9 also will return to the 1, because add 1 is in a 1. Whenever you will go for the 8, it will call again 1, and 9 again. Then it will need to return. After execution 5, it need to return. After execution again 5, it need to return. So this need to be remembered. We'll go with the algorithm so that you can understand. So we'll start one pass algorithm. So we have all the MNTC. I am told that MNTC, MDTP are omitted just to reduce the flowchart length. That's it. And we have MDLC, number of MDI we are not using, but MDLC we are using. That's what the counter. How many counters we are, how many macros are encountered. N is number of argument. Imagine it is also set to 1. Then SP is -1, means we are top of the stack. Yeah, we start reading read. Then it will go for the second algorithm, read. SP is 1, yes. Then continue reading the next statement, return to the main. So it will go again back. Then it will search for if there is a macro name matches. No, it is not macro name. Then first it is a defining. If there is a macro, yes. If there is a macro, then what it should not do, it should enter the name to the MNT, MDT, MNTC should be incremented, prepare argument list, MDT should be entered, MDLC should be incremented, again read, again a macro within a macro. If you found any macros, then again repeat that steps. This is the same. And if you have last MDLC means all the macro and amend are equal, then there is no other more macro definitions, then go to A, means again it will come over here. Then again it will set. What it will do, search for the macro name. Now all the macros are defined, all the macro within a macros also defined. Now we need to expand. So we need to search for the macro name. If there is a macro name found, yes, macro name is found. Whenever macro name is found, then what happened? Yes, macro name is found, you need to expand. Yes, then set SP plus N plus 2. Whatever you have a pointer, that need to be placed in the location SP plus N plus 2. Means if you have SP, we had what we had in a SP, S of SP we had -1. Clear? Hope you can understand. Plus what you have N, you have 1. So 1 and plus you have 2. So what happened? Plus 1 minus 1 cancel. 2. S of 2 2 you need to store SP, means SP is nothing but where you have a call. So what you will get, SP is add S data 1, data 2, data 3, where the line number is 6. Remember? So what is the line number? Line number is 6. This is stored because you need to return to 6 each time, right? This is stored in S of 2. You hope how you got a 6 over here, right? 6. Next location, so you got a MDT pointer where 6 is nothing but in a macro definition, line number 6 explain the macro definition of add S, argument 1, argument 2, argument 3. So SP is encounter. 6 is stored in a 2, S of 2. In the algorithm they had given the formula, plus 1 minus 1 plus 2, then S of 2. Then you need to point to the new location. You need to jump to the new location, that is SP plus N plus 2. So what is the value of SP? New SP is minus 1 plus N, that is 1 plus 2. Then you need to point to the second line, that is new stack, new value. Means whenever you have encounter, you will come to this line that need to jump to which one? Plus 1 minus 1 plus 2, means it should jump to the line number 2 where you have a add one's model statements. Model statement is load, add, store. Whenever you call this, it need to jump to the 2. So that's what we have written the algorithm formula. Is what a new stack pointer. You are pointing to the new pointer, that is what? 2. How you have set? SP plus N plus 2. So in the line you can check. Clear? So you are pointing to the line number 2 whenever you are encountered with the stack point number 7. Point number 7 in the sense, which line number? Line number 7. Whenever a 7 encounter, you need to jump to 2, right? So we'll do the same. Whenever the stack pointer is 7, you will jump to the MDT is 2. You will get L. Clear? Apart from next L 1 comma data 1. After that MDT is incremented, which is omitted in the algorithm, and you will go for the next line number, that is 3, and A 1 comma F is encounter, then 4. After that it should come again back, right? So for that, next check what each and every time all the MDT is incremented, that is what 2, 3, 4. This is what incremented. 2 MDT plus 1, 3 plus 1, 4. All the, then you will encounter with the M end. Clear? So this was the organization. So you can see that minus 1, 6 is the pointer. Next you have all the data. Address has the 3 data. 1 is a blank is used for the return address again. Clear? 3 datas are stored. In this again you can see that there is 1 data is stored. Now whenever you are, this is what the organization of a stack, this is what the implementation of a stack. Clear? Now you have got, now you need to return to the address, right? So you check all the arguments are red, all the arguments are in red are uploaded. You can see that all the arguments are red. Data 1, instead of #1 we replace with the data 1, #1 we replace with the data 1. So all the red. Clear? Then what you need to do, you need to repeat again. Go with the read if you have a macro call within a macro. If you have a macro call within a macro, definitely SP is not equal to 1 now. SP is equal to now 6, right? Sorry, SP is equal to 7 because you are in the line number 7, that program, right? You are in the line number 7. After that you need to execute with the 8. So SP is not equal to minus 1. SP is equal to 7 now. Is not equal to minus 1. Then if it is not equal to minus 1, it is equal to 7. So what you need to do, increment S of SP plus 1. S of SP plus 1. S of SP plus 1, s of sp plus 1. What is that? S of sp plus 1. So what you had in a s of sp plus 1? S of sp plus 1 you had 6, right? sp is 1, sp plus 1 is you had 6. That is, then increment that by 1, that is nothing but a 1. So that this is the first adds stack and this is what the add 1 stack. So you got a return address. Whenever you will go for the next, you have to return to 7. So you got a return address. Clear? You have to set that and repeat the task. You need to get all the argument list. Whenever you will get the argument list from the MDI and check if it is an amend. If it is not amend, clear, then repeat the steps. Else if it is yes, then it go for the check for MDLC. If it is MDLC is 0, clear, means there is no other macros, all the macros read and read n, everything is equal to 0, then you will complete, else you need to repeat the task. So this was the algorithm. Clear? So this is stack organization has been asked. So don't write all these stuffs, not required. This is the main thing. Explanation of this is this slide, how the stack is organization. So this is a 5 marks question, and apart from that you need to write the algorithm. This is algorithm. So this algorithm is very easy. This part is same as a past one. Till here it is same. Only these 4 lines you have to read. Whereas here also everything is same. Only the SP here, it's not MDI, it's SP, and it need to be incremented and argument list to be set. So both the algorithms are equal. Compare that and read using SPI, using MDI. Sorry, SP and MDI. So check that. The last topic we have, that is implementation of your macro processor with an assembler. Instead of having separate macro processor and separate assembler, we are adding macro processor task with the assembler itself, because if I go with the 2 pass of macroprocessor and 2 pass of assembler, it will take 4 pass just for converting. So instead of that, we need to club the macroprocessor along with the assembler. So what we will do, we will club macroprocessor as a preprocessor to an assembler. Means before assembler, a preprocessor will execute. That is nothing but a macroprocessor. Clear? Do a complete scan. Clear? Before a pass 1 of a assembler. Before a assembler pass 1, complete scan it will do. That's a preprocessor. Clear? Some later on we implemented that preprocessor activity within a pass 1 itself. Means whenever the assembler scans, in the same time microprocessor also scan with a single pass. It will define the macros and expand the macro. Clear? Here MNT is whatever it is using by the macroprocessor. It is combined with the MOT, mnemonic table, op table, what we have in assembler. MOT we call. Check the assembler chapter. We are combined that table with the content of MNT is combined with the MOT. We use a flag just to indicate that whether there is a macro name or not. And macro pseudo ops, instead of a macro processor, macro is always identified by the macro processor, but we incorporated in assembler that assembler directives which detects the pseudo ops should utilize the macro and perform the preprocessor activity. So how it has been implemented, is a small algorithm is given. So pass 1 while reading, only pass 1 is giving. While reading, search for the POT, nothing but MOT. If there is any pseudo op found, then macro pseudo op found, then enter into search the, if there is any macro name is found, then search in a MNT. MNT means you will search with the MOT and perform the required task. If it is for the call. For the definition, if there is any macros is found, then it will search what kind of a pseudo op, whether it's a macro pseudo op, whether it's an end pseudo op, or whether it's an other pseudo ops, whatever we have in a assemblers. Assemblers we have many pseudo ops, BALR, we had origin, begin, other. If you get, then it will, assembler will check. If you have a macros, then it is defined as a preprocessor activity and macros are defined, and then again it will repeat the task. When macro is defined and whenever the name is encountered, then it will search for the MOT and it will match. Whenever there is a match, it will expand. That's what the machine instruction, and again it will repeat. And if you have an end process, then it will terminate. So this was the macros within a assembler. So assembler only identify if you have a macro call. There is no explicitly macro processors. So this is for the macro definition, this is for the macro call. Macro call, nothing but searching for the name in a MNT, it search in across a MOT, because we merged the MNT table with the mnemonic table. So it will search in the same. If you have found, then it will set up the macro stacks and the frames, everything it will set up, and it will give. If you are not getting a macro call, MOT will search, and MOT whatever we add. We have 3 types of statements in that also: imperative statements, declarative statements, and you have one more AD, right? So that will be performed. Those are the machine instructions. We discuss with the machine instructions as well as the non-machine instructions. The last advantage and disadvantage of a macro processor advantage. Sorry, this I had left. It's the advantage and disadvantage of a macro processor. So add upon that. Clear? Macro processor advantage and disadvantage. Advantage is, do not have to implement if you are having macro processor within an assembler. It's the advantage of macro processors within an assembler. If you are, that's what the advantage and disadvantage of macro processor within the assembler. Implementation of macro processor within the assembler. So if you are having microprocessor within the assembler, then no need of the implementation of it twice, means 4 plus 2 plus 2, 4 implementation is not required. Overhead will be lesser, because in a one pass macros also be sorted out, assemblers also sorted out. Clear? And need not to be given an output of a macroprocessor should be given to the assembler. That task has been reduced. Need not to be created output from the macroprocessor to the assembler, because we are clubbed both the task and we are make it as a one. All the assembler features whatever we have along with the macro facilities are provided, so computer programmer get a flexibility. Disadvantage is the assembler pass 1, as it is combined with the macro processors, the size of a software is large and required more memory and very complex, and programming also very complex. Yeah, so this is the advantage and disadvantage if we incorporate the macro processor with the assembler. Yeah, so hope you understood what I told. In this algorithm, check your textbooks. This is for your reference, no need to read, means understand, that's it. Yeah, in our answer sheets you don't want to write this one. This is compulsory in your textbook. This is for your reference I had given. This is also, these 3 slides is for your reference, just to have these numbers I want, so that how the stacks will be arranged, because of we have a formula over here, right, for that sake. So understand the flowchart, learn the flowchart. One pass using MDI, one pass using SP, both are same except these parts. So check that. The remaining is same. Pass 1, pass 2, algorithms, macros, read it properly so that you can write. This is a pass 1 of 2 pass as macroprocessors. Same, you can check. All these parts are same, you can check, except you don't have a macros. This part won't be there. The remaining will be same of 1 pass, 2 pass algorithm. Clear? Understood? So read it first, 1 pass and 2 pass algorithm, then club both, analyze both, match both the algorithm, then read. So this was the macro chapter. End up with the chapter, that's unit 4 I think, macroprocessors. Thank you.